my name is Jeffrey. We're going to talk about sequences. We're not going to go too much in theory, but just the applications. So let's start. Question number 1. Find the first 5 sequences started at n equals 1. So wherever we see an n, we replace it with the number that we want. So we'll start from we'll start with 1. So a sub 1 will be 7c dot 1 for the numerator and 1 plus 5 for the denominator, which gives us 7, 6. A sub 2 will be 7c dot 2, 2 plus 5, which will give us finally 2. A sub 3 will give us 7c dot 3, 3 plus 5 for the denominator, which finally simplifies as 21 over 8. A sub 4 will give us 4 plus 5 as the denominator and 7c dot 4 for the numerator, which gives us 28 over 9. Finally, a sub 5 will be 5 plus 5 for the denominator and 7c dot 5 for the numerator, which gives us finally 35 over 10. But we can simplify by dividing by 5 on the numerator and dividing 5 on the denominator, which gives us 7 over 2. Thank you. For question number 2, find the first 5 sequences starting at n equals 0. So let us start. So at a sub 0 we get is 7 to the 0 power, divide that by 2c dot 0 factorial, which gives us 1 over 0 factorial, and 0 factorial is defined as 1, so our final answer is 1. So a sub 1 shall be 7 to the first power divided by 2c dot 1, which we can simplify as 7 to 2 factorial, which just gives us 7 halves. A sub 2 will be 7 to the second power divided by 2c dot 2, which gives us finally 49 over 4 factorial, which is 49 divided by 24. A sub 3 will be 7 to the third power divided by 2c dot 3 factorial, which gives us 343 divided by 6 factorial, which will be 343 divided by 720. And last but not least, a sub 4, which will be 7 to the 4th power divided by 2c dot 4 factorial, so that gives us 2401, so 2401 divided by 40,320, but we can simplify by dividing 7 on top and bottom, which gives us finally 343 divided by 5,760. For question number 3, find the first 5 sequences starting at n equals 1. So let's copy and paste. We replace all the n's with 1's here, where we can find out what a sub 1 is. The numerator will be 41 and the denominator will be 1, which simplifies to 41. So we can copy and paste and replace the 1's with 2, for we can find a sub 2. So the numerator will be 4. The denominator will be 87. So now we do the same thing but with 3. To find a sub 3, So 3, 3, 3, and 3. Our numerator will be 155, and our denominator will be 9. As we scroll down a little more, we will find a sub 4 by replacing the 3's with 4's now. Our denominator will be 16. Our numerator will be 245. And finally, a sub 5. So replace all the 4's with 5's now. So our numerator will be 357, and our denominator will be 25. For question number 4, find the first 5 sequences starting at n equals 0. So let's copy and paste. So a sub 0, and the n will be a 0, which gives us finally 1. We can press paste again and replace the n's with 1. And that gives us finally just negative 2/3. As we scroll down a little more, we'll do a sub 2. So that leads us to 4 over 9. Now we'll go on to a sub 3. Which will be negative 8 over 27. And finally, a sub 4. Which will give us 16 over 81. So we have all our first 5 sequences starting from 0. Question number 5. Find the first 5 sequences starting when n equals 0. But just remember, this is a recursion, so it's a little different. So let's start. So when n equals 0, therefore, wherever we see an n, we replace it with 0. That means a sub 1 must equal 5 over 11 times a sub 0. But we're given a sub 0, which is 3. Therefore, a sub 1 equals 5 c dot 3 over 11, which finally gives us 15 over 11. There we go. Now, when n equals 1, we will copy and paste just like we did before. We replace all the n's with 1 now. This gives us a sub 2 equals 7 plus 5, which is 12, so 12 over 11, a sub 1. But remember, a sub 1, we solved it as 15 over 11, thus 12 over 11, c dot 15 over 11, which gives us, well, let's get a calculator quickly. 12 times 15 gives me 180, so it'll be 180 over 121. Now we'll do when n equals 2. When n equals 2. Now, wherever we see an n, we replace it with 2. So a sub 3 equals 11. 7 times 2 is 14 plus 5 is 19. So we have 19 over 11. C dot a sub 2. But remember our a sub 2, we solved it on a previous one, which was 100. 1,000. Sorry, I misspoke. 180 divided by 121. So let's do that. So let us solve this. This will be 19 times 180, which gives me 3,420 on top. And 121 times 11 gives me 1,331. So now let's do when n equals 3. When n equals 3, we do copy and paste like we did before. So we replace all the n's with a 3. So we get a sub 4 equals 11 on the bottom. 7 times 3 is 21, plus 5 is 26. A sub 3. A sub 4 will now be 26 over 11 times C dot 3,420 divided by 1,331, because that's what our A sub 3 was. Let's simplify this. So we get is 3,420 times 26, which is 88,920 over 1,331 times 11. So which is 14,641. 14,641. And finally, when n equals 4, and we do just like we did before. Put a 4 there. And finally it'll be a sub 5 equals, whoops, I forgot to put the 4 there, which now gives us 7 times 4 is 28, plus 5 it's 29, 30, 31, 32, 33. So it'll be 33 over 11, a sub 4. We can simplify a little more and we get is 3 a sub 4. But remember, we know what a sub 4 is. That's what we saw before. So finally a sub 5 will be 3 c dot 88920 divided by 14641. Let me get a calculator to finally do the simplification. So I get is 88,920 times 3, which gives me 266,760. All over. Whoops, let's see why my mouse is doing that. 14,641. Question number 6. Find the first 5 sequences starting at n equals 0. So let's start. When n equals 0, therefore, let us copy and paste here. So replace the n's with 0. A sub 1 equals to a sub 0 squared. But remember, we're told that a sub 0 is 1. Therefore, a sub 1 equals to c dot 1 squared, which gives us 2. So now we do so now our next step is to do that when n equals 1. So when n equals 1. Therefore, a sub 2 gives me 2a sub 1 squared. But remember, we found out what a sub 1 is. So let's plug in. So a sub 2 equals 2 c dot 2, which gives us, oh, but we forget to square. Let's not forget that. So it'll be 2 times 2 times 2, which gives us 8. When n equals 2, I should write the therefore symbol here. So let's do that. And let's copy again. I like doing this on Microsoft Word because it's easy. So plug in 2. So we plug in 2. Let's simplify. This becomes a sub 3. It'll be 2 a sub 2 squared. That becomes a sub 3 equals 2 c dot 8 squared, which gives us 8 times 8 is 64, times 2 is 128, but I will verify. So it'll be 8. It'll be 8 times 8 times 2, and it was 128, so I'm good. So let's do when n equals 3. So now I shall put 3 plus 1, 2, a sub 2 squared, and that simplifies it to a sub, oh, shoot. I made a minor mistake here. Where did I make my mistake? Ah, there it goes. 3. Sorry about that. So we will have now a sub 4 to a sub 3 squared, which gives us a sub 4 to c dot 128 squared, which gives us, times up by 2, it'll be 32,768. So let's type that in. So finally, our last one is when n equals 4. When n equals 4, therefore, and we should also put that for the 3 too. We can do a little copy here. All I'm gonna do is just shift each one. So this becomes a 4, this becomes a 4, whoops, close, and that becomes a 5, and that becomes a 4, which makes a sub 5 equals 2 c dot 32768 squared. Oof, that will be a huge number. We'll see what that gives us. And then we times that by 2. And then select all. I'm going to plug this. Oof, wait, wrong one. Sorry. Copy. And then paste. And it'll be this humongous number. That's going to take me a while to pronounce. But that will be it for question number 6. We will now go to question number 7. For question number 7, find the patterns and type it in a closed form. So let's copy and paste this. So we have a 7 halves, but let's replace 4 with 8 halves. Let's replace 5 with 10 halves. And if you notice, the numerator is increased by 1 and the 2 is always the same. So we can finally say it would be n plus 7 over 2, and then we'll shift to the right here, where n shall start at 0. And there's your pattern here. I'll highlight it in yellow just to emphasize it. Starting at 0 if you want to. So let us go to the next question. And then we will have this question number 8. And we will do the same thing. Yeah, I gotta finish this now. Hello. For question number 8, find a pattern and type it in a closed form. So let us write that there. So we're going to write 5 over 7 to the 0 power, which is the same as 1. We are going to write negative 5 over 7 to the first power. We're going to write 5 over 7 to the second power, and then we will write this as 5 to the 7th with a negative to the third power. If you notice, it is alternating between the negative ones, and the ratio is 5 over 7. So we can now finally say C dots. Our closed pattern will be 5 over 7 to the nth power, and we will stick a negative 1 to the negative 1 on the outside, and that is our pattern starting at n is greater than or equal to 0. Thank you. For question number 10, find a pattern and type it in a closed form. So let us write this. So 1, we leave it like that. For 6, we're going to write this as 2, C dot 3. And let's stick also a 1 there. The next one will be 120. We can write this as 1, C dot 2, C dot 3, and C dot 4, and finally C dot 5. So for the next one, we will do the same thing. 1, C dot 2, C dot 3, C dot 4, C dot 5, C dot 6, C dot 7. And then the last one will be the same thing, but multiplying it with 8 and 9 now. So we can simplify a little here on Microsoft Word by copying and pasting here. And then I'll put C dot 8 and then C dot 9. If you notice, we can now simplify this a little more by writing this as 1 factorial, comma, 3 factorial, 5 factorial, 7 factorial, and 9 factorial. And if you see the pattern, we can now finally write this as 2n plus 1 factorial, where n starts at 0. For question number 12, find the limit as n goes to infinity of the sequence, if possible. So let's do so. As n goes to infinity, well, let's copy this sequence here. Now let's put an equal sign. Let's copy again and put paste here. What we're going to do is a neat little trick where the square root will be on the outside, so it'll be n squared plus 7 for the denominator and 169 n squared for the numerator, and the square root will be on the outside. So we can now press again copy, and we will put paste. We'll divide n squared to the numerator and the denominator, so it gives us 169 on the bottom and 1 plus 7 over n squared, which finally gives us the answer to be the square root of 169, which finally gives us the answer to be 13. For question 13, find the limit as n goes to infinity of the sequence if possible. So let's take the limit as n goes to infinity of cosine 5 over n squared, which gives us cosine of 0, which gives us 1. So the final answer is 1. For question number 14, find the limit as n goes to infinity of the sequence if possible. So let's do that. So as n goes to infinity, we will have the sequence above, which finally leads to 7. For question number 15, find the limit as n goes to infinity of the sequence if possible. So let's do that. So we'll take the limit as n goes to infinity of this sequence. So let's copy. And now we will divide by n squared to top and bottom. So that gives us over n. This will be n over squared. This will be gone. And this will be over n squared. So we finally get is 7/2. For question 16, find the limit as n goes to infinity of the sequence if possible. So let's do that. So as n goes to infinity of the sequence what we have here. Now let's make this easy by dividing n to the 1/4 to top and bottom. Which finally just gives us 1 as the final answer. For question number 17, find the limit as n goes to infinity of the sequence if possible. So let's do that. So we'll put an equation here. Take the limit as n goes to infinity of 11 to the 1 over n, which gives us 11 to the 0 power, which finally gives us 1. For question number 18, find a limit as n goes to infinity of the sequence as possible. So let's do that. So equation as n goes to infinity of n sine 1 over n. We'll press equal, and we will write this in a little more obvious way, for we can take the limit. We we will write 1 over n on the denominator and sine 1 over n on the numerator. So this gives us finally the same thing as the limit as n goes to 0 of the famous sine over n, which gives us 1. For question 19, see if this function is monotonic or not. So let's write this in its continuous form. So we'll have as 11x squared and then x squared plus 7 on the bottom. The easiest thing to do is use quotient rule. So d dx of, we will say g of x on top and then h of x on the bottom. And then this leads us to g prime of x times h of x minus g of x times h prime of x, and then h squared on the bottom. So let's find out that we will set g of x equal 11x squared. So g prime of x equals 22x. H prime of x will equal x squared plus 7. And then finally, h prime of x equals 2x. So now we'll start plugging in. So, copy, paste. G prime of x will be 22x. C dot h of x will be x squared plus 7. G of x was given to me as 11x squared. C dot h of x will be 2x, and then x squared plus 7 squared. Finally, we will simplify at the end and set the numerator and the denominator equal to 0. So it'll be 22x cubed plus 22 times 7, which we should get a calculator. So it'll be 22 times 7 is 154. X minus 22x cubed, and then we have this x squared plus 7 squared. Let's set it equal to 0. So we just get is 154x as the numerator, and we get x squared plus 7 squared on the denominator. So let's do each. 154x equals 0, and x squared plus 7 squared equals 0. So x equals 0 for the first one, and the other one is x squared equals -7, but we can't have any imaginary points. Therefore, x equals 0 is the only critical point, which is nice. But we don't have to do for both sides. We just need to do for one of the sides. So when 0 goes to infinity, because remember from the question here, we only care when n is greater than 0. So we do from 0 to infinity. Naturally, when you do critical points, you have to do from the domain of the derivative, but in this case we don't. So let's just choose a value between 0 and infinity. So let's just choose f prime of 1, which gives us 154 over 8 squared. We don't have to simplify this because we know it's a positive number. Therefore, we can say that the function f of x is increasing from 0 to infinity Thus, a sub n is a monotonic function from n is greater than or equal to 0 because it's strictly increasing. Just to make sure, a monotonic function is either strictly increasing or strictly decreasing. For the last question, number 20, see if this function is monotonic or not from n is greater than or equal to 0. We will convert this into its continuous form, so x e to the negative x over 5. So let's use product rule. So d dx of g of x h of x equals g prime of x h of x plus g of x h prime of x. Therefore, g of x equals x, g prime of x equals 1, h of x equals negative x over 5, and then h prime of x equals negative 1/5 e to the negative x over 5. So let's use product rule to finish it off. So it'll be e to the negative x over 5 plus x, well, minus x over 5 e to the negative x over 5 and set it equal to 0. We can do some factoring. E to the negative x over 5, and we will have is 1 minus x over 5, and we set it equal to 0, and we know x equals 5. So we found our critical point. So now let's make a little box here. So from the domain that we're given from, which is 0 to 5, and then finally from 5 to infinity. So let's choose a number between 0 and 5. So let's choose f prime of 1, which gives us e to the negative 1/5, and it'll be 1 minus 1 over 5, which gives me 4/5, e to the negative 1/5, which is a positive number. And to simplify this process a little more, we will replace this with a 6. So it'll be 6/5. So that gives me negative 1/5. As we can see, a sub n is not monotonic because the slope changes at x equals 5 from a positive slope to a negative slope. And like I mentioned before, to be monotonic, the function must be strictly increasing or strictly decreasing.